focus on for today across these two articles that you read is a pretty fundamental question, right? It's what skills and behaviors at school entry best help ensure school success? People have been asking this question for a long time, and there's a lot of disagreement about what those skills are. Some would say academic skills, some would say socio-emotional behaviors. We'll talk about those different views coming up. But in terms of the statistics, I want to be addressing two questions. The first one is kind of a correlational question, right? What skills and behaviors at school entry best predict school success? So prediction is all about associations. But as I've tried to argue throughout the quarter, life is too short not to aspire to causal questions. So the causal counterpart would be what skills and behaviors, if augmented in, say, preschool, best boost chances of success. All right, so that's a very causal question. We want to know, let's say you're running a preschool, you've got a choice of what kind of curriculum you want to adopt. Should it be oriented toward improving socio-emotional behaviors? Should it be oriented toward boosting executive function, tools of the mind kind of interventions? Or should it be oriented toward ensuring that kids know their letters and numbers? In other words, boosting early academic competence. And it's a really important question. Which of those curricula should you adopt if you want to best serve the kids in terms of their chance of making a transition into school and years later of being successful in school? So it's very much an intervention question, and people have developed preschool curricula with these different kind of philosophies in mind. So ostensibly, the analyses for the most part are non-experimental, but it's the old question: to what extent can you bring non-experimental methods to bear on the causal question, which is really the important question. So let me transition here. These slides are available on the syllabus. So if you want to follow along or look to that later, probably best just to follow along by looking at the screen. So this is an article that was published in Developmental Psychology about 15 years ago. It was a very ambitious project. You can see all the co-authors here. There were 6 different data sets and different subsets of people were involved in analyzing those. So let's get on with it. What motivated me to be interested in this? Well, one of the wonderful professional experiences I had was to serve on a National Academy Committee around 1998 is when it began. It produced a report in the year 2000 that tried to make sense out of the emerging neuroscience evidence coming out with respect to early childhood. There was a report called Neurons to Neighborhoods that came out of the National Academy. It was it was a really interesting group of people that produced this report. And one of the statements in it, one of the conclusions in it was based on a literature review, the elements of early intervention programs that enhance social and emotional development are just as important as the components that enhance linguistic and cognitive competence. Okay, so in terms of the big trade-off between skills versus behaviors, academic skills versus socio-emotional behaviors, this conclusion very much comes down on the side of it's both, right? These social emotional behaviors are every bit as important as the academic skills. And if you haven't noticed, I always get a bit grumpy when people do empirical research, and I try to review some of the literature that this conclusion was based on, and I was grumpy. So I never really bought into it. I wondered what would happen if it was done in a somewhat different way, if there were more control variables, various kinds of things that you could do to investigate whether the research was very robust, and that kind of percolated in my head for a while. And then I had a chance. Well, okay, so let's do a little more background first. Sorry. So what are we talking about when we say school readiness? If you ask kindergarten teachers who you think would be best able to define what school readiness is all about, is it the letters and numbers? Is it the socio-emotional behaviors? There was a big survey of kindergarten teachers, and what they identified as being most important for kids coming into their kindergarten classrooms was being physically healthy, rested, and well-nourished, being able to communicate needs, wants, and thoughts verbally, being enthusiastic and curious and approaching new activities, and knowing when to sit still and pay attention. All right. And only about 10% of kindergarten teachers thought it was important that children started school knowing the alphabet, for example. Their attitude was, if a child comes in with the kind of social and emotional behaviors that will make them a receptive student, I can teach them those things, right? Just make sure that the socio-emotional behaviors are all lined up, and then I'll take it from there. So kindergarten teachers don't say they're equally important. Kindergarten teachers say the social emotional skills are much more important, plus health, for example. So that's one view. Right around the year 2000, 2001, when George W. Bush became president, there was a big push with No Child Left Behind as the big legislation. And the No Child Left Behind, it wasn't related to preschool or birth to 5 at all, but it was all about K-12. But the idea was that, as you can see in this quote, on the first day of school, children need to know letters and numbers. They need a strong vocabulary. These are the building blocks of learning, and this nation must provide them. Right? So the whole thrust of No Child Left Behind was all about academic skills. And No Child Left Behind put in place a very elaborate system for measuring performance of schools and school districts, and having penalties in place if school districts were failing to reach acceptable standards of these kind of academic skills. So it's, in terms of consensus, there is no consensus. So we did this article and sent it off to Child Development, which is one of the premier developmental journals. This was actually supposed to be staged in, but anyway, what happened to our article, our submission? it was rejected outright. Didn't even make it past the first review. There was no revise and resubmit. I remember one reviewer thought it had feet of clay. I remember that quote. So they just didn't like it. They didn't think it was done in the right kind of way. I think some of the critics were people who had the view that social and emotional skills were the most important or were equally important. And as we'll see, the article really didn't come out supporting that. But one shouldn't let one's prior beliefs influence a review. But for whatever reason, it was rejected outright. All right. So, it ends well. It was published not in Child Development, but Developmental Psychology, and is one of the most highly cited articles in developmental psychology. So it turned out well, but it's interesting that it was rejected the first time around. So if you get to the point of sending off articles, which you will pretty soon, and they get rejected, there's hope. There's hope. There's always other journals. All right. So we're interested in these two questions about prediction. To what extent do school entry, academic attention, and social emotional skills? So I had set this up so far in terms of academic skills and social emotional skills. There's also things like executive function, which I'm calling attention skills. So we want to know about correlations. And then the second point, we want to know about implications, causal implications for interventions prior to kindergarten. All right, just to be clear, what are we talking about in terms of early achievement? It's the kind of things that you would expect, right? Reading skills, early skills, knowing letters, knowing beginning and ending word sounds. There's a lot of variation among children who are entering kindergarten in terms of how much of this they know. Some know very little, and some are much more advanced than that. With math, it's things like counting, knowing which number is bigger than what other number, relative size. So these are just the elementary math skills that are the building blocks, and reading skills that are the building blocks for later achievement. Beyond the cognitive skills, actually attention is really a cognitive skill, but an ability to sustain attention. Executive function is a very important concept now. Back when we were doing this 20 years ago, it was just starting to emerge as an idea. So the data sets that we had not collected direct measures of executive function, but most of them included some sort of questions about attention problems. So we wanted to include those. Socio-emotional behaviors, developmental psychologists divide this up into externalizing socio-emotional behaviors, externalizing behavior problems, acting out, not getting along with teachers or peers. So that's the externalizing part. Internalizing is more a mental health kind of dimension, kids who are withdrawn, quiet. So they're quite distinct from externalizing behavior problems. And then related to this, which are measured separately in some of the data sets, are social skills, ability to relate to other children and teachers in an appropriate manner. Okay, so those are all the kind of skills that we want to be measuring and then relating to later school success. And what the article does, if you have questions, just feel free to interrupt as we go along, please. The study, as I say, was ambitious. We had 6 data sets. They were all longitudinal. They were all non-experimental. They all began either at kindergarten entry, or most of them began prior to school entry. They all followed kids for a number of years, most of them second, third, fifth grade, some of them longer than that. And all of them had measures right at school entry of that set of reading skills, math skills, attention skills, socio-emotional skills, social skills. They all had measures of those things taken around the point of school entry. And then they all have later measures of school success, which in this article we define as a composite, well, of later math achievement, later reading achievement, and a composite which combines those academic measures. We did play around with some other outcomes, but what I'm going to talk about is really focusing on school success defined by doing very well by third grade or fifth grade along achievement kind of criteria. And importantly, almost all 5 of the 6 of these data sets have measures of IQ or some other kind of cognitive ability measure prior to school entry. All right, so and going from the prediction to the causation question, it's helpful to have these prior measures. All right, so let's ground our discussion with a data set that you now know well, the ECLSK, and I want to illustrate the kind of models that we estimated. So you know exactly what the ECLSK is about. At the time we did this article, there were data available through third grade. Now it runs through 8th grade. And you have some idea of the kind of measures that are going to be available. So let me stop the screen share and talk about the empirical approach that we took. So we've got a data set like ECLSK. We've got 5 other data sets too. And the analysis we want to do is to take some kind of achievement composite in, say, 5th grade, and we want to take all of the after kindergarten measures of achievement. If 1st grade, if 2nd grade, if 3rd grade, all those things become outcomes for the analyses that we run. And we want to relate that to school entry, achievement skills, school entry, socio-emotional behaviors, and we consider attention skills to be separate, but let's ignore that for a minute. So we've got some measure of school success, and we're regressing on school entry, reading and math skills, school entry, externalizing behavior problems, internalizing behavior problems, and so forth. And let me ask first, pretend like you're back in Drew Bailey's class in the fall quarter when he talks about internal validity, right? So we want to identify, ideally for the second question, a causal impact of school entry achievement skills on later school success. The causal impact of school entry socio-emotional behaviors on school success. What stories of omitted variable bias with an equation that's this simple would be problematic for us? In other words, what kind of controls do we want? So, you know, and I want you to give me a chat, give me a sentence that says, well, everyone knows kids with brown eyes do better than kids who don't have brown eyes, therefore, and brown eyes is both boosting school entry skills as well as later skills, so you better control for brown eyes. All right, so that's obviously a trivial example, although I do have brown eyes. But fill in the blank. What other than, or instead of brown eyes, should this analysis control for if we want to convince you that we're starting to get from correlation to causation? So I just put it in the chat. X is important because. Okay, so Vanessa says quality of home environment. That could both affect scorediness as well as later achievement independently of early skills. SES, home language, home language environment. All right, parental education levels. SES is coming up. Again, parenting factors, income. Number of books in the home. Neighborhood differences. Neighborhoods could control for, or could have an independent effect affecting both school entry skills and behaviors as well as later academic success. What about characteristics of the child themselves? Family size, that's a good one. There's a pretty reliable literature showing larger families, individual children in larger families have a bit less. All right, developmental, a bit less in terms of scorediness. Developmental delays. DLD, okay, sorry, Molly, can you spell that out? Thank you. Delayed language disorder. All right. How about on the social emotional side? What early characteristics of children would you like to control for to clean up the causal impact of school entry socio-emotional skills? All right, exposure to academic language is Brian's. Interactions with other people, family structure, that's another element of SES. Siblings. Okay, so it's a pretty long list. I was thinking of temperament, right? Early temperament you might want to control for. Early measures of cognitive ability. I mean, people talked about developmental delays, but just a general measure, if you have an age 3 measure of IQ, you know, IQ is a pretty powerful correlate, and it's likely to affect both school entry academic skills as well as have a continuing effect on school success later on. So we like to control for that. Let's see what we actually ended up doing. All right, so the equation separates out these components of school readiness, right? Reading and math are distinct. We have these attention skills, externalizing behavior problems, internalizing behavior problems, social skills, plus various family and child measures that you talked about. You might worry that putting in so many concurrent in the ECLSK fall of kindergarten competencies might cause a lot of multicollinearity, but in fact, these things are not that highly correlated. There doesn't seem to be any evidence of multicollinearity problems. We're able to take advantage of a few other things. In ECLSK, it has both teacher-based reports as well as test-based measures of achievement. And then not in the ECLSK because it starts in kindergarten, but in all of the other 5 data sets. There's a prior IQ measure, and there are prior measures of temperament or behavior, socio-emotional behaviors. So all those things are available for control. All right, so let's continue with this ECLSK example. In this case, as I say, it runs to 3rd grade. What we did with the ECLSK analysis was choose components of reading and math that had no overlap whatsoever with kindergarten, right? So we didn't want any sort of spurious correlation if we're measuring the same thing in kindergarten and the same thing in 3rd grade. So these advanced subscales, extrapolation, evaluation for reading, multiplication, division, place value, and word problems. None of the kindergarten kids get any points when you ask those problems, and varying numbers of 3rd graders score, at various points on these subscales. So those are dependent variables that we're able to use. We also had available teacher reports of reading and math on this so-called academic rating scale. We'll be able to use those in a second. For kindergarten entry measures, there's the achievement tests again, and now we're looking at the elementary subscales on those tests, letter recognition, beginning and ending word sounds. For math, counting, ordinality, relative size, all those things are well measured in the tests at school entry in the ECLSK. And there's not an IQ measure, as I said, but there's a scale of what's called general knowledge, which is really kind of early science and social studies content. So if you want to clean up reading and math for general knowledge in terms of a control, you can include that as well. And for the socio-emotional behaviors in the ECLSK, there are both parent reports as well as teacher reports. And the teacher reports cover self-control, interpersonal skills, these externalizing behavior problems, internalizing. And then there's a scale, approaches to learning, which is kind of an attentiveness scale. So you can run these models, 3rd grade outcomes as a function of kindergarten entry plus controls, And as you know, ECLSK has a lot of controls for SES, family structure, not early home environment. You can get that in some of the other data sets. Plus classroom fixed effects, right? So ECLSK samples 4 to 6, I think, kids per kindergarten classroom. And if you're worried about things like neighborhood influences, most elementary schools are local schools in the sense that kids in the immediate neighborhood are attending their local kindergartens. So if you think about what classroom fixed effects do in terms of control for potentially omitted variable bias, you're just looking in effect within the 6 kids who are in a particular kindergarten classroom and see which ones are scoring relatively higher and lower on knowing their letters and numbers and having a teacher report of these problem behaviors. Of those 6 kids are the kids who score relatively higher on those assessments doing relatively better in 3rd grade, right? It's focusing all the variation to be explained within the classroom. And what fixed effects does is estimate that relationship within each classroom, and then it averages across all the classrooms. So the neighborhood effects shouldn't be biasing the estimates because all the kids in a given classroom, almost all the kids are from the same neighborhood. And similarly, it's classroom fixed effects. So anything that causes parents to self-select into a given school, a public school versus a private school, or even into a classroom, right? If they know anything about the teachers, sometimes parents are pushing to get their kids into the classrooms of certain teachers. The fact that you're doing fixed effects for classrooms eliminates differences in those kind of biases too. So it's a very powerful additional way of controlling for potential omitted variable biases. Let me just, I have talked about fixed effects in a couple of different ways. Let me make sure that point is clear. Does everyone see how powerful classroom fixed effects is in this kind of context for essentially controlling for neighborhood differences, controlling for parent obsession with the teacher their kids get, and so forth?
So to that point, but then so you're assuming that all the children in a classroom, because they're in that school, they're from a similar neighborhood, but then that wouldn't necessarily be true, right? For example, like in my high school, it was most of the students came from a lottery system, even though it was a public school. But then in that very specific instance, then that means the students aren't from that neighborhood. And then you would technically need to control for both classroom and neighborhood effects then?
Well, how about your kindergarten?
I have no
Same thing in
idea.
your kindergarten?
Well, okay, what if we assume that like a kindergarten has a lottery-based system?
Well, it's not going to be universal, what I'm saying, right? But by and large, the vast majority of kids, especially in elementary school, are attending their local school, right? So to the extent that's true, before you get into, lotteries often come in middle school or high school, right? With charter schools and things like that. I mean, this is also, 20, 30, 25 years ago. Actually, it's almost 30 years ago now. So there were many fewer charter schools, right? And much more, well, not much more, there still is, just most kids attend their local school. But to the extent that they don't, and there's elements of choice that parents have, then you probably don't have kids from the same neighborhood necessarily. But you do control, you know, if these are kids in a private school, but ECLSK is sampling both private schools and public schools. That kind of parent selection is still controlled for, because you're just looking at kids whose parents have selected them into the same classroom. Any other questions? So I don't want to be reading your class papers and saying, why didn't you use fixed effects when you're in a position to use fixed effects? It's something that rarely happens in developmental psychology kind of settings. I've never understood why not. It happens in some education, but it doesn't come naturally to people, because it's not a technique that is typically taught as being an important statistical adjustment, and its potential advantages are enormous, because it allows you control for things that you can't measure. So at the ECLSK, you're able to do the conventional, in this case, third grade achievement. Fall K math, fall K reading, fall K teacher report of externalizing behaviors, right? Plus teacher reports of a lot of other things, and all these family control variables that I talked about. So that's one way of estimating this model. Another way, if you really want to know what the relationship is between early skills and third grade or fifth grade or eighth grade achievement, another way to do it with the ECLSK is, let's say, third grade achievement. So if early things matter, they ought to matter at school entry, and they ought to matter at the end of kindergarten, right? If you're predicting the third grade from the end of kindergarten. And moreover, you know, think about this model: C plus D1 growth in math across kindergarten, growth in reading across kindergarten, change in externalizing across kindergarten, plus about all the other stuff, but controlling for fall K math, fall K reading, and so forth. All right, so we're relentlessly trying to make our equation provide more convincing kind of causal impact estimates for these kind of behaviors. But think about this. So, you know, if math really makes a difference, it should certainly show up as making a difference from this regression that we have begun with. But it should also be the case that the kids who gain the most across kindergarten in terms of math, controlling for where they started in kindergarten, ought to be doing better in third grade. Okay, so these gains in kindergarten don't come from a random assignment experiment, but they come from naturally occurring changes in math scores across kindergarten. But we're controlling for where kids start in terms of math at the beginning of kindergarten, right? So if the kids are all put at the same starting line in terms of kindergarten entry math, kindergarten entry reading, kindergarten entry behaviors, and we let kindergarten play out, and some kids are going to be gaining more in math than others. Some kids are going to be gaining more in reading than others. Some kids are going to be either becoming more or less problematic. Is it the case that the kids who are learning the most in math, controlling for where they started, end up doing the best in third grade, right? So that it still isn't an experimental analysis, because these changes are not randomly assigned. We didn't put them into an intervention that would boost these skills. So these are all naturally occurring, but it would be, if math really matters, then the kids who gain the most in math across kindergarten, controlling for where they started, ought to end up doing better in third grade. All right, so it's just another check on which of these elements of school readiness is most predictive of third grade success. Any questions about that? Or let me say, what questions do you have?
I'm gonna be honest, I'm still having a hard time understanding what differentiates a fixed effect from just like a regular old variable. Is it because it's something that just like can't be changed?
So you're going back one step, right, to the fixed effect analysis. No, no, not at all. I mean, in fact, well, let me just explain what it is. And to say fixed effects isn't very illustrative, but what it does, in effect, is take suppose we've got fall K math and third grade achievement. And we look just within classroom 1. All right, so 6 kids, every kid has fall K math measured. Every child is followed until third grade and has third grade achievement measured. And if early math matters for third grade achievement, this is controlling for everything. Controlling for other skills and behaviors and background. So this isn't a simple correlation. This is a regression that's got a bunch of stuff controlled, right? So if math controlling for other stuff, maybe the other stuff matters, then we're not going to have much relationship between fall K math and third grade achievement. But suppose we've got in one school kids that cluster like this, suppose there's another school where kids are coming in with a little bit more math from their family environment. We've got another group of kids that look like that. Each group of kids is a separate classroom. So let's just take the black dots. That's one classroom, and kind of estimate a best fitting line there. Same way with the green, and same way with the blue. And we're going to force these lines to be parallel with one another. That's an important element to this. So, what fixed effects does, classroom fixed effects, allows for a separate intercept for every classroom. Assuming you're doing classroom fixed effects. You could do school fixed effects, you can do various kind of fixed effects. So you're forcing, what fixed effects does is allow for a different intercept, but not a different slope, okay? So you're taking, just the black dots and estimating a slope. So the only variation between fall K math and third grade achievement, after adjusting for these other things, just comes from the 6 kids in that one classroom, right? And the only variation that you're taking advantage of to estimate the blue slope is the 6 kids who are in the blue classroom. And same way with the green slope, right?
So we're changing our A?
Yeah, exactly. So you can think of fixed effects as, this equation plus whether classroom, a dummy variable for whether classroom 1, and then a dummy variable for classroom 2. All the way out, 1,000 classrooms, you've got 999 of these dummy variables in there. So every single one has a separate intercept. Okay, so the only variation that feeds into your estimate of this slope comes from within each classroom. You are forcing them all to be the same, slopes the same, but intercept different. And so what that means is, when the only thing that you're taking advantage of to estimate the coefficient on fall K comes from within classrooms, anything that is difficult to measure leading kids into that particular classroom, living in the same neighborhood, having parents who are oriented toward public schools as opposed to private schools, having parents who are obsessive and insist their kids get teacher A versus teacher B. All those kind of factors that might potentially influence math scores of kids coming into school and later achievement, all those factors are unimportant because there's no variation that they're producing that you haven't controlled for with this fixed effect. You're only estimating these slopes from variation within kids in the same classroom.
Got it. Thank you.
Okay, it's a subtle point, but it's incredibly powerful if you think about it, right? Because the usual way we think about regression is just to add more control variables. And what fixed effects does, and you can estimate it by putting in 999 dummy variables, or Stata has XT reg, which is a procedure where you just say, use this particular variable, the classroom ID, which, it takes on 1,000 different values, and it will do it for you without, you don't care about, what the actual intercepts are. You just care about making the adjustment by allowing for different intercepts in order to estimate the slope, because that slope is going to be a much less biased estimate of what the relationship is between these two variables, because you're only estimating it based on within classroom variation. It's a subtle point, but it's extremely important. It's a very powerful way of approaching things. Okay, well, let me stop there. So, any other questions about fixed effects? What about questions about this approach? Does everyone see how, if one of these elements is important, it should certainly show up in the first equation. But if it's important, it should show up in the second equation also, because, in the case of math, naturally occurring changes in math growth, kids are different in terms of their math growth across kindergarten, and kids who are growing the most ought to be most successful controlling for where they started out. So it's just another formulation that amounts to yet another test that you would hope would produce similar results to this equation. So this version of the model is not in the developmental psych article. We could not convince reviewers that it was worthwhile. So we ended up publishing this in another article, but I always liked it. It's another, you always look for additional tests that you can perform to see if results hold up. All right, so let's go back to screen share here. So here are the results. ECLSK, we've got third grade reading achievement, third grade math achievement, full set of controls, including classroom fixed effects. Here are the kindergarten entry measures that are available, right? We've got tons of family controls and so forth. And as you can see, it's like someone described the solar system as Jupiter plus a bunch of rubble. And the results here are achievement measures plus a bunch of rubble. We have consistently predictive, interestingly, a bigger coefficient. These are standardized coefficients, right? So one standard deviation increase in math, controlling for all these things, controlling for family differences, controlling for classroom fixed effects. One standard deviation increase in school entry math is associated with about 1/4 of a standard deviation increase in reading, and then half a standard deviation increase in third grade math. Reading is a relatively important predictor of reading, not so much reading to math. General knowledge is important for both, but all these kind of socio-emotional behaviors, this last one is the executive function measure. So it's significant, but the standardized coefficient's much smaller than the early achievement. All these are insignificant and essentially zero. So it seems to be the case that once you control for where kids are academically coming into kindergarten, the kids who show greater self-control don't do better in third grade. Kids who act out more don't do less well in third grade. So it's, it's, if you are rooting for these variables to be as important as the Neurons and Neighborhoods report implied, you're not going to like this. All right, any questions or comments about this?
If the achievements are measured by reading and math, and you have measures of early reading and math, wouldn't it be quite obvious that the other variables and measures wouldn't be significant?
Well, after the fact, it seems pretty obvious, but go back to what the Neurons and Neighborhoods report said, that school success is every bit as much a function of socio-emotional competencies kids bring into kindergarten as their early academic skills. So a lot of people, and kindergarten teachers wouldn't agree with that either. They want to see kids who are healthy. They want to see kids who can sit still. Those are the things that they think are important for later school success. So it seems obvious, but only after you've peeked at the results.
Would the results be different if early on reading and math weren't in the equations for achievements measured as third grade reading and math then?
I think I've got a slide on that. They are, simple correlations are in the right direction, but they're still pretty small. So yeah, I think I have a slide about that. Let's see. But, one threat to these results, maybe it's just the fact that some kids don't do very well on tests, right? They really they know reading well, but they don't take a good reading test. So instead of third grade reading tests as the dependent variables, you can look at the teacher report of third grade reading and the teacher report of third grade math. And as you look down this column, you get, this general knowledge isn't as big, but math is every bit as big here, somewhat smaller here. The overall picture that you get, of these first three things being important, of the executive function report as being important, and these things as being uniformly unimportant, that those conclusions don't change at all when you switch from a test-based to a teacher-based report. All right, what about this other equation, that this change equation, right? So, if we look at changes in reading across kindergarten, controlling for initial reading level, changes in math, and so forth. Again, we're just looking for big trends here. And it's, again, the first four are all statistically predictive of reading and math. These socio-emotional competencies are unpredictive, and then approaches to learning, kids who gain the most in terms of approaches to learning across kindergarten, controlling for initial approaches to learning, end up doing better in third grade. So, you would hope this is just another kind of test of the model. Do the results fall apart when you try this alternative model? And the answer is no. Okay, so that's just one data set. We really did this across 5 other data sets. You can see a list here. In contrast to ECLSK, these other data sets had just extensive prior controls for children's behavioral competencies, cognitive measures, Those can be added in. And here's the more general result. So every single time from these data sets, these 6 data sets, we had some sort of outcome measured after kindergarten. We took the standardized coefficient and let me turn off my phone here. Okay. So, you know, the ECLSK estimates we saw of early reading and later reading, the reading outcomes are squares and the math outcomes are triangles. So you get, you know, pretty powerful predictions from ECLSK, somewhat less powerful predictions from in the other data sets. But by and large, regardless of when you measure the outcomes, regardless of whether it's math or reading, you end up with positive and often respectable standardized coefficients. Math is even more the case, right? There's the smallest standardized coefficients are about 0.1. They range all the way up to 0.5. We saw that in the ECLSK. You know, most of them are 0.2 to 0.3. You know, in contrast, the measures of attention skills never get above 0.2. They're usually positive, but some are negative. And then for internalizing, externalizing, and social skills, you know, you're getting a mix of positive and negative coefficients. The hypothesis is that, you know, these are problem scales. So you'd expect higher problems to be associated with negative effects later on. And if anything, you know, there are more that are positive than negative. Social skills is measured in a positive direction, but you know, that's pretty much centered at 0. So to try to summarize these results, we took all 236 of those estimates. So across 6 data sets, whenever we had a post-kindergarten measure of math or reading, we ran this regression, we got the standardized coefficient, and then those 236 observations became observations in a meta-analysis that we did. So if you take the 236 estimates and have the estimate size as the dependent variable and classify whether that estimate was for school entry reading, school entry math, attention, externalizing, internalizing, and social skills. You know, not surprising given what we just saw. The average on these reading coefficients, 0.16, math 0.34, right? That was the fact that these math coefficients were generally higher than the reading coefficients. Attention, much smaller, although positive. You know, again, those are the attention coefficients, and they average around 0.1, 0.09 to be exact. And then there's nothing going on average for externalizing and social skills. So Young-Sun, this kind of addresses your question. These are just the simple correlations, right? So don't have any controls at all. And just look at the simple correlations between kindergarten entry, reading, and later achievement. Pretty robust correlation, 0.44, 0.47. Attention, 0.25. The simple correlations with externalizing and internalizing are negative. So, you know, when a teacher reports a child is having more acting out kind of behavior, they indeed end up doing worse later on. It's not a big correlation. Social skills are positive. So this has no controls whatsoever. And once you put in all the controls, then you get adjustments down to these numbers. All right, when you separate out math and reading outcomes, this earlier table combine them, but if you separate them out, not surprising, math is predicting math. What is surprising is that math is every bit as predictive of later reading as early reading is. All right, so that's a bit puzzling. We started thinking of ways of the ways in which learning math kind of systematizes the way you think about things. There are all sorts of hypotheses you can come out with. And as we will learn from the second study we're going to review, that should have been a signal that maybe you've got some biases here that you haven't been able to control for. But that will come up very soon. We look for interactions. Is it the case that these skills are more important for low SES kids than high SES kids, Black kids, Hispanic kids, white kids? We didn't, or gender interactions, no consistent evidence of interactions. Toward the end, we're running out of time for this part, but we did look at various threats to these kind of points came up in the review. I showed a little bit of this before. Academic skills later on were as predictive of teacher reported as test-based outcomes. We saw that in the ECLSK. What about nonlinearities? These are all just linear models. We fit spline functions to allow for the sensitivity. It could be that being really low in math as opposed to somewhat low in math makes a big difference for later achievement. But once you get up to some decent level of early math skills, maybe there's no additional benefit in kindergarten. So we looked systematically for slope differences when you fit spline functions to these early competencies, separating out the bottom third and top 2/3 of their distributions, but no consistent evidence of nonlinear effects. You can read this final section of the paper. Here exactly is the with achievement controls and without achievement controls, right? So everything else is controlled for. If you control for family background and everything, but not achievement, then you get a 0.13 average coefficient for attention. That falls to 0.06 when you do control for school entry, reading, and math, but just nothing else is changing here when you add in the school entry math and reading skills. All right, so on and on and on and on and on. This, by the way, was my job talk for UCI. This is published in 2007, and I gave my job talk in 2006, and I guess I passed muster because I was offered a job. All right, so on the basis of this analysis, we drew the conclusions in the article, Kindergarten Entry Math is quite predictive of math, net of cognitive ability, reading. Skills matter, but somewhat smaller effect sizes than math. Attention skills somewhat seem to matter somewhat. Socio-emotional behaviors don't make the grade at all. And then too soon to draw firm policy conclusions, but the results suggest the wisdom of experimentation with early math and reading interventions in preschool programs. All right, so it turns out that when you actually do run an experiment with early math, this wonderful picture built up from this article totally falls apart. So let's take a break, and then you can come and see how this, how Drew Bailey, I'm blaming Drew Bailey. He joined the faculty here, what, 5-6 years ago. We started talking about this stuff. He, as you know, has this very contrarian view of things. And I couldn't talk him out of his positions, and he could talk me out of mine. And this wonderful preschool math intervention came along. And at the end of the day, I'm disowning this article in favor of the second article that we'll turn to after we take a break.
What happens
John.
if you have, like, let's say there is a really well-cited study, but then that was published in like 2006, and let's say it was proven wrong by a study in 2018 that didn't get many follow-up like citations. So if someone in 2019 or 2020, for example, is doing like a literature review and they find the study from, what did I say, 2007 that was proven wrong, like, is there any way to sort of like update, like on the search engines, is there any way to sort of like update which studies have been updated? Because like, is there ever a situation where someone cites a study that was proven wrong, but they never found the paper to prove it wrong? So they just kind of assume that, oh, it's correct, and they move on with their lives?
I'll talk about this. It's a very interesting. You know, later on I'll show you. If you ever read the signature of my emails, there's a line and it said, Duncan et al. 2000 right, didn't get it right, read all about it here. Right, and that's a link to this risky business paper. So, you know, I try to self-advertise that it's wrong. You know, another thing I was going to show you, here's Google Scholar, right? Citation history, there are 70, well, how many? 69 citations to this 2018 article. I guess came out at the end of 2017. So, you know, there were 14 citations, 23, 26. So, you know, citations to this are growing every year. But on the other hand, if you go up to school readiness and later achievement, you know, this is getting 626 sites in 2020. And, you know, Risky Business came out in 2018, and it looks like it's still going strong. So either people don't know, or, you know, Drew was presenting his paper at a conference once, the Risky Business paper, and he overheard someone at the conference say, I'm still going to cite Duncan 2007 because I need the money. You know, all these early math people love school readiness because it kind of shows how important early math skills are. And Risky Business is kind of throwing cold water on that idea. But this person was just going to keep going with 2007 because it supported the proposals that this person was writing to get more money to do early math stuff. So there's a certain momentum that gets established. And I don't know if, you know, my goal is to not have this be the most cited article that I've written, but I'm not sure I'm going to be able to make it.
Gotcha.
All right. Yeah, go ahead.
No, I was just saying gotcha.
Okay. All right. So let's go through this. So this is not a kind of a general look at all the different school readiness measures that we considered in the 2007 article. This is focusing on the especially the math skills, because that's where this intervention, this successful math intervention focused on. But, you know, just as a starting point, oh, I should do screen share, right? Oh, so you didn't see any of the other stuff I did with the Google citation? All right, sorry. Anyway, we are talking about the processes by which reading skills get built up, math skills get built up, and so forth. And this is all very well documented, right? And it's part of the reason why we thought the 2007 article was so spot on. In terms of math, there's this very well documented sequence. Kids learn to count, they learn addition, problem solving, and then they learn subroutines of multiplication problem solving. All those things flow steadily from simple skills to more complicated skills. Same way with reading, phonemic awareness begets written word recognition, vocabulary, and then reading. All these things are very solidly documented in the literature. And there are more general models. Cunha and Heckman have a more general model of these processes. So we're really talking about a sequence of, in this case, math skills that are measured longitudinally. And the issue empirically, let me switch to the board here. So this is all it is, right? We can keep going out, math skills 4. We could do this for reading skills. We really believe, and there's a lot of evidence to back it up, that these sophisticated skills, more sophisticated skills, are products of prior, more simplistic skills, right? And that there's a fairly well-defined process by which simple skills evolve or are developed, I should say, into more complicated skills. You could have the same kind of sequence for reading. So the empirical question, you know, we kind of took this fact to support the intuition. You know, if this is kindergarten entry, let's say, and this is 3rd grade or 4th grade math. It's not surprising that kids who come in to kindergarten with higher levels of math skills have higher levels of math skills in 3rd grade. You know, the causal question is, if you augment these skills, right? Let's say in pre-K, would you expect there to be a causal impact on math skills later? And Skordinas' article clearly hints that that is the case. All the tests of robustness kind of established all the attempts to remove omitted variable bias. But if you think about this kind of skill building process, you can easily have this process at work, and yet math skills at time 1 are very unpredictive of math skills at time 4 through this process if these links aren't that big. All right, so, you know, if the coefficient on here was 1.0, 1.0, 1.0, if there was a lockstep relationship between early math skills translating into math skills a year later, and a year later, then there would be, if that was a causal sequence and coefficients were 1.0, then you would have this lockstep relationship between early skills and later skills. But the links between math skills 1 and math skills 4 is the product of the path coefficients. Right? Remember we talked about mediated models? There was X, there was Y, and then there was a mediator up here. And the indirect effect of X on Y operating through M, the mediator, was the product of these two paths. So if these are 1.0, then 1.0 times 1.0 times 1.0 is 1.0. But if this is pretty high, 0.5, 0.5, 0.5, then the causal link between time 1 and time 4 is 0.5 times 0.5 times 0.5, right? So now we're down to a much smaller number. And if it's 0.3 times 0.3 times 0.3, we're down to a very small number, right? So it's not enough to say, yes, there is this process by which early math skills are built upon for more sophisticated math skills. The relationship has to be sufficiently lockstep for this to be have a causal effect on that amounts to anything. And that's really an empirical question, because you can have, more sophisticated skills come from earlier skills, but also a lot of other things that happen in between, right? And that would reduce the size of these links. So it's all about empirically, what are the size of these links? Let me share my screen again.
Excuse me, I have a question here. If
Yes, please.
it's okay, yeah. So wouldn't that imply that the effect of, for example, math skills at time 1 is just directed through times 2 and 3? Wouldn't that just like eliminate every other path that math skills at time 1 would affect that?
So it's possible that the model, let's take away this. It's possible that there would be direct effects of very early math that didn't operate through the intervening variables. Is that what you're talking about?
Yeah, or maybe just like math at time 1 affecting at time math at time 3 as well, something like that. Other
it could be.
that, yeah.
Yeah. But there are a lot of other things that are influencing these things as well. So that's a good question, and it's hard to distinguish. It's hard to estimate these paths that are independent of the step-by-step, but it's also hard for me to imagine what kind of process this link would consist of, right? So early math skills, being able to count, ordinality, those kind of elementary skills, are they likely to have some independent effect 3 or 4 years later, independent of your addition and subtraction, you're knowing something about fractions and so forth? It seems like those early math skills are so elementary relative to the more sophisticated ones that come up later on, that it's hard to come up with plausible stories about why that should be the case. Maybe so, but that's what you need to do in order to have those kind of indirect routes that you're talking about. Okay, so let's move ahead with this this paper. It was fun to trash quotes from the 2007 paper. And this one, kind of says, well, we nailed the causal impacts. We implement rigorous analytic methods that attempt to isolate the effects of school entry, academic, and so forth, that may be related to children's achievement. You've seen these results. And so this paper really says that this conclusion in 2007 is likely to be wrong because the tests don't hold up to, even though they held up to a lot of different robustness checks. There are others that we could have done. And we also have this idea that an alternative theory, which combines modest skill building, right? In other words, 0.3 or 0.4 set of coefficients, plus remaining bias from persistent factors, explain the data better. This idea of risky tests from Paul Neal, he writes about this, and it amounts to the probability of observing large longitudinal correlation in the absence of strong skill building processes is high and not low, because other processes might be producing them. So the paper focuses on comparing what the 2007 paper's analysis is all about with RCT results, but there's also mention of the within and cross domain patterns of correlation, and then not in this paper, but other analyses we did focus on sibling fixed effects, sibling differences, to try to get a handle on omitted variable bias. So let's do the RCT experimental manipulation. As I tried to point out when we talked about the 2007 paper, we really wanted to try to approximate what would happen if you had a preschool intervention that succeeded in boosting, let's say, math skills, right? That's what we were trying to approximate when we were looking at the coefficient on school entry math skills. Well, it turns out that there is such an intervention that was rolled out after we did our 2007 paper. Doug Clements and Judy Sarama are at the University of Denver. They're wonderful people. They've really done a very good job of thinking carefully about early math development and coming up with a really interesting intervention called building blocks that is to be implemented in preschool classrooms. It's mostly kind of play-based. There's a little bit of a computer component, but it's not very important. So it's very thoughtful. It's a lot of fun. Kids have fun learning math. And it takes about 15 to 20 minutes of class time a day. So it's a very promising kind of intervention, and they did everything right in terms of an evaluation. They did a cluster assignment evaluation where they allocated groups of schools in Boston and Buffalo, either to get preschools rather, either to get the building blocks intervention or business as usual, no special math intervention, and good response rates. It was very well done. So they ran building blocks over the course of the pre-K year and measured. They had a very nice early math test. They measured at a baseline before building blocks began. They measured at the end of pre-K when their intervention was done. And they generated very large impacts on overall math and components of math. So, being in the treatment group rather than the control group classrooms was associated with about a 2/3 of a standard deviation higher score on this math test. The test has components. You can see what the impacts were on the components, biggest impact on geometry, but significant impacts. All these standard errors are about 0.06. So all these things are significant and pretty sizable. So it was an effective intervention that at the end of preschool had a fairly robust impact on quite a number of important components of early math learning. All right, so what did we do with these data? Well, we first wanted to see whether the building blocks control sample was weird in some important way. So maybe the 2007 populations were from all over the place, 3 different countries, including a couple of national samples. Maybe these samples in Buffalo and Boston were different enough so that you couldn't generalize results from them to the kind of populations that we were using in the 2007 paper. So to look at this, we first did the kind of non-experimental analysis that we did in the 2007 paper to try to see if we got similar patterns of correlations. And here are these are not experimental differences. These are just the correlations adjusted for control variables. So this is the correlation between end of treatment math. Let me see, end of treatment math and school entry or end of kindergarten math scores, end of first grade, end of second grade, and so forth. So of course, sorry. This is end of treatment is definitionally correlated 1 at end of treatment. If you go a year later, you get a correlation of 0.6, adjusted correlation. These are the kind of effect sizes that we were seeing, math being quite predictive of later math. A year later in second grade, it wasn't declining much, then it drops a bit. So by 5th grade, you were getting standardized coefficients on these control group kids where early math was generating an effect size on later math of about 0.4, right? So that was kind of in line with what the ECLSK was showing. So it looks like the control group kids look like the kids in the 2007 article, and these we have confidence intervals around these amounts. But generally, it's a pretty strong, slightly declining pattern, which is exactly what you see in the 2007 article. All right, so big test. What happens if you actually look at the pattern of experimental impacts, right? So, in the 2007 article, we were kind of thinking that when you put in all these control variables, as we did with the triad control group here, you would start to get something approaching an experimental impact. You'd start to get something that you would see if, in fact, you ran an experiment and were able to boost math scores in the pre-K year by a lot. And we did some rescaling here. The initial impact we took the initial impact was about 0.64, remember, 0.63, and rescaled that to be 1.0. So it was the same as the control group non-experimental regressions. So at that point, we forced to be the same. And then we tried to see to what extent the control group prediction matched the experimental impact a year later. These are pretty close, right? The experimental impact was about 0.5 or so. The correlational equivalent was about 0.6. So far, so good. But then you go another year to see how much of a lingering effect there was in the experimental impacts in second grade. And you're down to a 0.2 effect size, in contrast to something 3 times as large from the correlational estimates. And the further out you go, the worse it becomes. Things start to become insignificant by the time you get to 4th grade. And then, or I guess this is 3rd grade. They did 2 measurements in 4th grade, and then this is 5th grade. So it comes up a little bit in 5th grade, but still it's significant. So by and large, you've got no lingering impact of this strong, highly successful pre-K math program after 2nd grade here. In contrast to these persistently high correlations, adjusted correlations from the control group. So does everyone see what these differences are? Does everyone see how much anguish this could cause for someone who was thinking that he had really nailed it with the 2007 analysis? It's not right at all. Math does not have continuing impacts, early math, once you get out a couple of years. That's very clear from the triad. This is building blocks was part of a more complete intervention called triad, but this is the building blocks math intervention. So you get this very, very different picture on what the long-term impacts of early math skill augmentation is. It's not quite high, it's 0. It's indistinguishable from 0. So this is, this was my my excited aha moment. Momentarily disappointed, a little bit embarrassed. We had convinced ourselves that the early math result was really very important. I had given this talk a lot of times. New York City implemented a really expensive version of building blocks on the basis, not of these results, because these results weren't available, but on the basis of the correlational evidence that that I went and presented. Everyone was convinced that this building blocks intervention would produce permanent improvements in kids' math, but that didn't seem to be the case. So, does experimental manipulation reproduce the results in the 2007 paper? No. And then we took a closer look at the within domain pattern of correlations. So, if the skill building models are correct, then you'd expect that the prediction of early math to later math ought to be a lot higher than early math to later reading, right? Or later anything else. But is that the case? Well, so this is back to the ECLSK, right? So the math to math pattern we just saw in building blocks is fairly similar. These are just correlations. These aren't adjusted for anything. Reading to reading, a little bit more of a drop in correlations, but it's still 0.5 by the time you get out to 5th grade. And similar correlations if you look at early antisocial behavior to later antisocial behavior. All right, so what about cross-domain? Well, superimposed on what we saw before, this is the pattern of early math predicting later reading. Now, you know, if you really believe in this skill building model, math should be predictive of later math because it's an important input into later math, but reading, not so much. And it turns out, if you look over here, that the early math to later reading correlation is almost exactly the same as the early math to later math correlation. That, you know, we were trying to think of substantive reasons why the kind of math skills would be that you would be bringing into reading tasks might be helpful for reading, but we really hadn't thought about ways in which those two things, that early math could actually be as predictive in a causal sense of later reading as later math, and that shows up in this correlational kind of evidence. So, you know, it should have alerted us to the fact that that there are other things going on probably. And, you know, the most obvious one is that there's some kind of more general cognitive factor that might be leading to these correlations between early math and later reading. And we tried to control for IQ and so forth. But, you know, something's not right in the skill building story if you've got these kind of correlations that are very similar. Everybody with me so far? I worry that there's not much discussion. Yeah, go ahead.
Yeah, so wouldn't that be like a sign of a general intelligence concept?
Yeah, that's what I was trying to say. Now it is true in the 2007 article, we had IQ measures and other general cognitive measures available at age 3 or age 4 in all but one of the data sets. It's not available in ECLSK, but it's available in all the other data sets. So we thought, you know, if you control for a decent cognitive test score for that child at age 4, in looking at the partial relationship between early math and later math, that you would be controlling for that general cognitive factor, right? So, you know, maybe you're not controlling for it well enough. Maybe there are other things going on that are producing, you know, other omitted variables. Okay, so we didn't, you know, we should have predicted weaker declining correlations for math to reading than math to math, but and be, you know, very skeptical when we didn't see it, but we really didn't pay as much attention to that as we could. There's another thing that we did that ended up not making it into the paper. You remember sibling differences are another kind of fixed effect, right? Sibling fixed effects, which control for persistent differences that siblings in the same family share, right? So the sibling difference version of this would be, do siblings that differ in school entry math differ in later math or later reading in the same way that non-siblings do? If so, then you'd have a robust result to sibling fixed effects, but let's see what happens. So in this case, there's a data set, the NLSY, National Longitudinal Survey of Youth, the child sample has a lot of siblings in it, and they've got test scores measured repeatedly and so forth. So just a reminder of the gold standard here. This was the building blocks experimental impacts that faded out. If you look at these NLSY patterns, you get something very similar to what we just seen. Bivariate, things drop, but then are pretty constant in terms of correlations, early math to later math. If you put in simple controls, which is race, ethnicity, gender, this Peabody Picture Vocabulary Test is controlled for. That's receptive vocabulary, but it's thought to measure quite or correlate quite highly, 0.8, 0.85 with a more general cognitive test. Maternal years of schooling, so you're controlling for SES to some extent. And things drop, but they still are, 0.3 or so by the time you get out to age 11 and a half. If you add in full controls, these are some of the other things that people talked about at the first part of the class. The preschool home environment, maternal cognitive ability, that's available. Things drop more. And then you can do sibling fixed effects to try to see if you control in addition for other factors that siblings share that are persistent, you get a further drop. Right? So, by and large, NLSY has so many controls that you get most of what sibling fixed effects do. But the overall pattern here now is, an adjusted correlation that's less than 0.2, whereas it was almost twice as high when you had a control regression. So what this is saying is, that even though we put in a lot of control variables, we may not have completely captured everything that was important behind these correlations. And it may be the case that there are still more unobservables that are producing these correlations that we observe. So there is this alternative model that we tried out. You can think about it as layered on top of these skill building models. This is just what I had up on the board. Math skills at times 1, 2, and 3. You've got these paths linking them. What if we allowed for some persistent factor, unmeasured, that was affecting all these math scores that you observe, right? This is we call the state trait model. It's horribly misnamed because when you think of trait, you think of genetic traits, but in fact, in this model, these unmeasured persistent influences could be anything. They could be neighborhood differences that were having these persistent effects. It could be family differences that were having these persistent effects. So you don't know what it is, but if you allow for there to be something, and you can estimate this model, and see, you can see, I mean, it kind of boils down to, if these are 1.0, then you've got this kind of lockstep relationship between early and later math. I said if they're 0.5, you'd have 0.5 times 0.5. So it's really important to estimate what these paths are in the presence of these kind of controls for unmeasured persistent factors. So we did kind of a literature review. Most of the work is Drew's actually, and some was Tyler Watts. So if you look at estimates from these state trait models to try to see what the coefficients on these paths are that you multiply, you get a path, an average path of 0.35, right? So this is 0.35. This is 0.35. The effect of early math on time 3 math is 0.35 times 0.35, so not very big. There's another way that you can. So this is just showing you if you've got early math predicting 1 year later with a 0.35 path, it's 0.35. Once you get 2 years out, you multiply the two together and get 0.12. By the time you have 3 years out, 0.04, 4 years out, 0.02, and so forth, right? So if you believe the skill building model and these 0.35 coefficients, then you would expect to see this kind of pattern of fade out from an early math intervention. And indeed, that's exactly what you find, right? Now we're going back to what the experiment showed. You get this pattern of decline in terms of impacts. If you take the 0.35s and multiply it out at what this trajectory would look like, you're getting something that's coming pretty close to what the experimental impacts actually were. There's another way that you can estimate these coefficients. We don't have time to really go into it, but now it comes up with a 0.44 average path. And if you put that in, that's the darker dashed line. With 0.44, you're getting something that's very, very similar to what you get with the experiment, right? So we've got a model, a non-experimental model that is taking advantage of an ability to adjust in some way for these persistent unmeasured influences on all these math measures, that is producing an implied decay in the effect of early math on later math that comes very close to matching what you observe when you actually run the random assignment experiment. All right, how about questions? I'm running ahead of myself.
Greg, I'm kind of curious about something. Do you think you would be so open about what you call your mistake if you weren't a tenured and distinguished professor? Like if someone was in mid-career, do you think that if they were open to their mistake, this would hurt their career?
It's a good question. I mean, it's mid-career, the tenure decision comes after 6 years, right? So that's still pretty early on. People writing tenure letters tend to you tend to pick people who are, quite distinguished in a particular field to write letters. And some of them are pretty doctrinaire and some of them aren't as open to contrary evidence and might object, might not write a good tenure letter. You don't want to be in that kind of situation, right? You really want to be in a situation where if something doesn't look right, you ought to be able to say it doesn't look right. But what this really implies is that if something doesn't look right, then it's your job to figure out what's going on, right? And if in your career you discover mistakes, big mistakes, but that leads you to think differently about something and to be able to conceptualize it in a very useful way, then it's going to enhance your career, I think. So in my mind, what all of this says is that if you merely have a successful preschool curriculum, and do nothing else, you're not going to have much of an effect on kids' school trajectories, right? There are just too many other things going on once kids get into school that make that initial boost disappear. On the other hand, if you think of this as you probably do, and some other people do, as not just a preschool issue, but a preschool to second grade or a preschool to third grade issue, right? If you can set up a preschool intervention that is quite effective and can set up a kindergarten curriculum where you can have some kids that haven't had this intervention and are going to be coming in needing to build up their basic skills, but you're going to have kids coming in after having had the intervention who need enrichment, right? You need to be taking all the kids. I mean, it's certainly important for kindergarten teachers to make sure that all the kids have basic skills by the end of kindergarten, right? But that doesn't imply that you can't work with kindergarten teachers, perhaps with a curriculum that's lined up in the right kind of way, that simultaneously ensures basic skills on the part of kids who need them, as well as continued progress, right, for the kids that already come into kindergarten with substantial math skills that came about from this intervention, right? So, it's this difficult question of how do kindergarten teachers and first grade teachers deal with a lot of heterogeneity in their classrooms. It's really tough to be able to teach simultaneously to kids with a lot of different initial levels, right? But there are curricula that assess kids routinely. This is more the case in reading than math. You find out several times a year where kids are in terms of reading. Depending on where they are in terms of reading, you get a curriculum for the child that will take the child up to the next level. It might be level 2 to level 3. It might be level 4 to level 5. So, it has implications, and it's a tough thing to think about, but you simply can't stop at the end of pre-K and think you're done. That's what all this implies to me, because building blocks had this big impact, 2/3 of standard deviation, right, at the end of pre-K. There was something there that could be built on, but apparently wasn't. And Doug and Julie actually had an enrichment curriculum for kindergartners and first grade teachers, and the teachers who were trained in that kind of enrichment, it's kind of a recognition. It's working with elementary school teachers who, by and large, aren't. They're much more interested in helping kids read than they are helping kids with math. So it's in part helping teachers understand, what the nature of skill development is in early math, and it was able to reduce the fade out by maybe a third. You'd really like it to eliminate all the fade out, right, and keep the impacts persistent. But it's that kind of implication that this risky business leads to, that you start thinking about once you reject the 2007 results and start thinking more integratively about what the problem is. Okay, so let me just thunder down the home stretch here. The usual caveats. Tom Cruise, if you're going to see risky business, chat yes. Is it on Netflix, Tiffany?
To be honest, I just streamed it. I don't think it's on Netflix, but I can send the link to the group chat.
Okay, yeah, please do. I mean, there are a lot of other things to do with your time, but that is my story, and Any final questions? Now we do have this this supplement, so I don't want to. I keep thinking 2007 paper is going to take an hour, 10-minute break. This paper is going to take an hour. We'll be done at 3:10. The supplemental talk that I did yesterday is going to be another hour's worth, 50 minutes worth. That kind of makes up a week's worth. But here we are, 3:30. So I'm neglecting the chat. Brian, did you have anything?
No, I was just kind of, as you was talking, I was just like, even like the part where you was talking about like your professional career. I mean, even as a student coming in and you sharing that story, it inspires me to be a better scientist, to take in new information and learn and grow. It just inspires me to be a better scientist, and so, yeah.
It's, you end up not being liked sometimes and you're grumpy all the time, right? And that's not good. You got to kind of turn it off at the end of the day when you're with your family, right? And that's a little hard to do sometimes, but I think in the long run, you're going to get more done. You're going to help more people, right? If you really understand what's going on. So that's the hope. That's the hope. Okay, so as I say, I will post some meeting times on, I think, Wednesday. I'll have to look at my calendar when I don't have the search, these interviews taking up all day. Certainly Friday, and I'll try to get to the natural experiment paper grading by the end of the week. All right, see you all next week.
Greg, I was just curious of how other co-authors of the 2007 paper took the risky business.
Yeah, it's a good question. It was like water off a duck's back. I have not I have not heard any recognition from any of them that the 2007 article wasn't right. I'm not, I don't know what, I can't account for that. I haven't sat down, I haven't had occasion to sit down with the group and kind of go through risky business and talk about the implications. But it's for a developmental psychologist to give up on longitudinal models. That's asking a lot because that's everybody's livelihood, right? If you really, one hopes that quite a bit of the longitudinal research isn't like risky business in the 2007 article, but I don't know. I just totally, I can't bring myself to review articles anymore that just use those kind of longitudinal methods, because I know it's not fair, because I just know I'm going to write this kind of negative review, and how can you be sure that you've controlled for? Most of the time people don't control for much of anything, but they certainly don't look in a creative way at threats to the conclusions that they reach. Just to preserve the careers of younger people, I don't accept reviews of papers where I'm going to be grumpy. Anyway, it's been a great learning experience for me, and I hope you too.